Okay, I hope I'm starting over because I want to start over. This is my video for you for Limacon. So actually it's Limacon. It's Francais. There should be like a little accent actually underneath there like that. You probably can't really see that, but it should be Limac with a little accent, ONS. All right. So I'm going to start out like we did with the rose curve. We're going to take a picture like r equals, I don't know, maybe 4 plus 4 cosine of theta. And just like I did with the rose curve, I'm going to add on here 15-degree little sections so that way I can show you the whole picture. And of course, we'll have to go the opposite direction with these as well. And then I should probably go ahead and get my second and fourth quadrants ready as well. So while I'm doing it, I should have done this before I started hit record, but you know, is what it is. Got a new iPad, so I'm super excited. So this is a bigger screen and I've got more to work with. So I'm kind of excited. All right, I'm gonna make a little table here, just like I did before. And I'm gonna go by 15-degree increments just for fun. And we will start by first just going from 0 to 90. And then we'll go from there. So 30, 45, 60, then 75, and then 90. Okay, I'm going to be plugging everything into my formula, or not the formula, but the given equation. So those angles are going to be going right in here for theta. So I'm starting with my 0 degrees. So of course I know what the cosine of 0 degrees is. You should. That's 1. 1 times 4 is 4. 4 plus 4 is 8. So I'm going to plot the point at 0 degrees out to a circle of radius 8. Then I'm going to go to 15 degrees next. But I don't know what that one is without a calculator. So cosine of 15 times 4 plus 4, that comes out to be about 3.93. Just make sure I did that right. I am in degree mode. I multiplied by, oh, wait a minute. You know what? It's not right. Cosine of 15 times 4 plus 4, that's about 7, excuse me, 7.86. Whoops. Sorry. It's about 7.86. So I'm going to go over to a circle, or excuse me, angle of 15 degrees, out to a circle of about almost 8, but not quite, so about right there. Okay. 30 degrees. So cosine of 30, you know that the cosine of 30 is the square root of 3 over 2, but I do want to get an approximate decimal, so times 4 plus 4, that's about 7.46. So at 30 degrees, I'm going out to a circle of, not much different than where I was. So about right there, okay? Cosine of 45 is the square root of 2 over 2, as you know, without a calculator. But again, I'm trying to get this to be, so I can plot it. So that's about 6.83. So at 45, I'm out to a circle of 6, and then like maybe about right here. Did I go out too far on that one? No, 7.4. Yep, okay, so my graph is doing something. It started actually here, and then it's coming around like this. Okay, so this is what we're looking at so far. And I've got you on a different platform here because I'm recording it through Zoom basically, but I want to be able to show you my calculator in a minute, so that's why I'm doing it this way. Alrighty, then I'm going to go to 60 degrees. I wasn't replacing it here, so I'm just going to put this as theta. So cosine of 60 degrees is 1/2. 1/2 times 4 is 2. 4 plus 2 is 6. So 60 degrees, I'm at a circle of radius 6. Just there. Okay, again, I'm trying to make these like nice and smooth and curvy, but easier said than done sometimes. Alrighty, 75 degrees. We don't know that one without a calculator, so cosine 75 times 4 plus 4 is about 5 point something. 5.04. So 1, 2, 3, 4, 5, barely a little more than that. So coming in there. And then the cosine of 90 is 0. So then 0 times 4 is 0, plus 4 is 4. 1, 2, 3, 4. Okay. We have quite a ways to go. This is not nearly the whole entire picture. So I'm going to have the video automatically pause here while you guys finish it, and I'll have some questions popped in there for you like I did before with the other Ed puzzle. Okay, unpause that so that hopefully you can just see I went up to 180 degrees. This is not the entire picture. We would have to keep going. But everything from here on is going to give you the exact same thing. So what will happen, if you hadn't already done so, is basically you would keep going with your 15-degree increments over here, and it would be the exact same thing as what you had, but working in this opposite direction. So we would go to, let's see here, this is 195 degrees next. So 195 degrees would give you 0.136. 210, so 195 would give you the same piece here. 210 would give you the 0.54. 225 would give you the 1.17. 240, and so on and so on to what's next? 255. And so on. So that would keep on going till you get to 270. When you get to 270, you're going to have a radius of 4, and so this continues on. So again, I'm going to pause it while I finish, and then you can finish. Okay, so now that you've got the whole picture drawn, hopefully you realized you did have to go all the way from 0 degrees to 360 degrees to see this entire picture. I wanted to start with this type specifically. This is what is called a cardioid. It is a type of a limacon. So all the ones that we're going to do today, they're all classified as limacons or limacons, or people say it all sorts of ways, but the appropriate, because it is French, is limacon. And this is specifically a cardioid because it kind of looks like a heart. And if you think of like cardio or your cardiovascular system or cardiologist, they pertain to your heart. So that's where that name comes from. So I actually would have known that from here. So this is another one of the goals. If we had been in class, this kind of stuff would have been non-calculator. I already knew, because of the way that this was written, that, excuse me, that this was going to be rough, what's it called? Symmetric on the x-axis. And that's because we're looking at a cosine. And I also knew that it was going to go out to the max point over here, out to a point of 8. I knew that it was going to go up and down on the 90 and the 270 to a value of 4. And I knew that it was going to come in and just touch the origin and swoop back out. So I already knew all that information because of what I know about limacons. So that's the goal, is that you too would eventually get to that point. If you are eventually going to go into Calculus BC or Calculus 2, then those are things that you might need to know without a calculator at some point. So we are going to talk about how I knew that information. So we're going to start with the, I'm just going to show you examples of all that are symmetric on the x-axis. And so in that form, Let's just draw a little piece here. So the form